Next, we want to discuss singular matrices, and a matrix is singular if its determinant is 0. For example, here's some example. For example, if you have a matrix, say they have the matrix A, and A is, say, for example, 4, 3, 6, 2. And I ask you, what's the determinant of A? Determinant across multiply and subtract, right? So this is 4, 6. So the determinant of A will be 3 times 4, which is 12. Take away 2 times 6, which is also 12. Alright? Determinant 0. So you have a matrix B. Let's give you some examples. You have a matrix B. Let's say the matrix B is 6, 5 and 10, 3. And I ask you, is the matrix B singular? And how will you determine if the matrix B is singular? You find the inverse of B. Right, so determinant of B would be 5 times 6, which is 30. Take away 3 times 10. And by the way, a matrix, so this is 30. This is 0. So B would be is a single. So B is a singular matrix. So when we say singular in matrix theory, it's not like in English grammar where singular means 1. Alright, in matrix theory, singular means the matrix has a determinant of 0. Alright, so a matrix is either, and we don't have plural matrices, right? So it's a singular and non-singular. Good? And the thing about these matrices, they do not have an inverse. So remember the formula for inverse of a matrix: 1 over determinant times adjoint. So if a matrix, this is the inverse of a matrix, right? 1 over determinant times adjoint. So and it makes perfect sense that it does not have an inverse, because think about it. If the determinant is 0, then A inverse will be 1 over 0, and 1 over 0 is undefined. Right? So these matrices do not have an inverse. Good? Here our problem here. Given that the matrix x12, 3x is singular, find the values of x. So we are told that this matrix is singular. And if it's singular, it means that the determinant is equal to 0 if it's singular. Now what's the determinant? X times x, and what's x times x? X squared, and then 3 times 12. What's 3 times 12? 36. So if this matrix is singular, we're not trying to cross multiply x times x, take away 3 times 12. It gives you the determinant, but it's singular, so equate it to 0. So this means x squared equal 36. And if x squared equal to 36, then what is x? The value of x will be plus 6 or minus 6. And here's the reason why. If x is 6, what's 6 times 6? 36. And you get 36 minus 3 times 12, 36. But what if x is negative 6? X can also be negative 6, because if x is negative 6, what you'll have here is negative 6 times negative 6, which gives you the same positive 36. Take away, and the 3 times 12 is 36. So if x is 6, it will be singular. If x is minus 6, it is also singular.